Okay, fine. So I'll just start with today's video with electrochemistry. That is the topic of discussion for today, right? So you know, in electrochemistry, as you can see in this screen, we'll talk about electrochemical cells and how to calculate the potential of a cell. That is the what is the reduction potential, what is the EMF of a cell, electromotive force of a cell, and how is it related to free energy, what are the relevant questions being asked in GET metallurgy. We'll solve some problems from previous year's questions as well. So let's move on, let's go ahead with this topic. So as you can see, I'll just show you. In an electrochemical cell, you might be remembering something else from your Part2 where you read it already. I'll just recapitulate all those. There are electrochemical cell, there are two separate reactions. Okay, in one cell we call it a half cell. So a electrochemical cell is divided into two parts, right? We call it half cells. In one half cell there is a reduction reaction taking place, and in another half cell there is an oxidation reaction taking place, right? So based on this this reactions, finally we combine these two cells to form an overall EMF of a cell, and we can measure it by, you see a voltmeter over there, 0.340 volt is showing. So what are the reactions? For example, in these reactions, I guess they have taken an example of copper, copper sulfate. So copper is being deposited at the anode. So always remember lone, left, oxidation, anode, negative. So negative charge accumulates at anode. It's also we call the left side or left hand. I will tell you why it's left, because in here we can see it at the right. It's nothing to do with the physical position of the cell. It's to do with some convention that we'll put forward. So left anode, left oxidation, anode negative, that is lone. And the other half cell, that is here the hydrogen, the hydrogen is being as hydrogen is evoluting as a gas. So H plus electron, and it's hydrogen emits out of the system, so it's H2O. So basically what happening is that there's a copper sulfate solution, and and you just this is this copper electrode, I guess, and you have put some I guess H2SO4. So basically in sulfuric acid you put a copper inside that. There's a CuSO4 and H2. That's what is being done here. Okay, it's not, sorry for saying as a CuSO4. There is some amount of Cu2SO4 also forms, but anyway, it's basically H2SO4, and copper displaces hydrogen. So to form CuSO4, or we say, let's see what displaces what at the electrochemical cell. So the main thing is that there's a one cell where there's a reduction reaction taking place, here in the case hydrogen, and in another cell there is a oxidation reaction taking place, that is copper is being deposited as a pure copper as a metal at the anode. So these are two separate reactions, and we call it this is